to our esteemed partners from the Tao Foundation for Culture and the Arts, the Protected Area Management Office of the Agusan Marsh Wildlife Sanctuary, Indigenous Peoples leaders, scientists from the DNR Ecosystems Research and Development Bureau, conservation agencies across Asia and Europe, local government officials, researchers, peatland dwellers, and all advocates, magandang araw po sa inyong lahat. I am honored to join you on the occasion of World Peatlands Day, a global commemoration of one of the Earth's most vital and yet underappreciated ecosystems. Let me begin by expressing my deepest gratitude to Dr. Grace Nono, President of the Tao Foundation and a steadfast partner of the Climate Change Commission, for her visionary leadership in organizing this event. Dr. Nono's dedication to bridging cultural heritage and ecological advocacy is transformative. Now, last November, during the CCC Solidarity Night, she moved us all with her impassioned call to protect Philippine peatlands, a call that continues to resonate in our world today. Peatlands are more than just wetlands. While they cover only 3% of the Earth's surface, peatlands store twice as much carbon as all the world's forests combined. Here in the Philippines, these ecosystems are biodiversity hotspots, water regulators, and cultural sanctuaries for indigenous communities. Yet when drained or degraded, peatlands release centuries' worth of stored carbon into the atmosphere, accelerating global warming. Therefore, their preservation is an urgent necessity. The Philippines National Adaptation Plan identifies ecosystems and biodiversity as one of the 8 key priority sectors for climate change adaptation. This forms part of the CCC's broader commitment to nature-based solutions, recognizing that ecosystems like peatlands are our greatest allies in climate action. But let us be clear, the CCC and the government cannot do this alone. The success of these programs hinges on collaboration with local governments, partnerships with NGOs, scientists, and you, the custodians of these lands. Today's event exemplifies the power of unity. As we celebrate World Peatlands Day, let us remember that the land we care for is the land that will care for us all. To our partners and advocates, the CCC stands with you. Let us continue to amplify the voice of peatlands, not just today, but every day. May we leave this event not just inspired, but more importantly, ready to act with urgency. Maraming salamat po. Mabuhay kayong lahat. Mabuhay ang Pilipinas.
To our dear guests, Dr. Grace Nono, Director of the Tao Foundation, local officials of the Protected Area Management Office of the Agusan Marsh Wildlife Sanctuary, led by Supervising Ecosystems Management Specialist Ms. Sherilyn Vasquez, the Agusanon Manobo Tribe, led by Datu Romy Reyes, to our dear partners, my fellow environmental advocates, and wetlands and peatland warriors. A good day to all of you. Maayong adlaw sa tanan. June 2 marks the annual observance of World Peatlands Day. This global campaign, led by the International Peatland Society, shines a spotlight on one of the most valuable yet vital ecosystems of our planet, peatlands. The highlight of our celebration are a very powerful natural resource. In fact, peatlands store more carbons than all the world's forests combined. This year, we focus our celebration on an important and relevant theme, protecting wetlands for our common future. This theme resonates deeply with the people in Southeast Asia. The ASEAN region holds a significant amount of the world's peatlands, approximately 25 to 30 million hectares in total. This represents 6% of all global peatlands and about 40% of tropical peatlands. This unique type of wetlands can be found in the vast peat-swamp forests of Indonesia and Malaysia, as well as the smaller but equally significant peatlands across the Philippines, Thailand, Vietnam, and Brunei Darussalam. These ecosystems are not simply wastelands. but they are integral parts of our landscape. They are home to a number of unique flora and fauna, provide us with water sources. They are a great source of livelihood for our people and ensure our survival. They serve as our silent yet formidable ally in the fight against climate change. Well-managed peatlands lock away thousands of years of stored carbon, preventing their release into our atmosphere and helping to regulate global temperatures. The ASEAN has existing frameworks and regional agreements for the protection of peatlands. The ASEAN Peatlands Management Strategy or APMS 2023 to 2030 was developed to achieve healthy and resilient peatlands by 2030 by enhancing knowledge and awareness, addressing transboundary haze pollution and environmental degradation, and promoting sustainable development. There is also an ASEAN agreement on transboundary haze pollution to prevent, monitor, and mitigate transboundary haze resulting from land and or forest fires, including those on peatlands, through concrete national efforts and intensified regional and international cooperation. To achieve a haze-free ASEAN by 2030, the second roadmap for ASEAN cooperation on transboundary haze pollution control with means of implementation from 2023 to 2030 was developed in 2023, while the ASEAN Task Force on Peatlands was conceived to support the implementation of the APMS. The ASEAN Center for Biodiversity, or ACB, recognizes the critical importance of peatlands ecosystems as carbon-rich natural resources. Just recently, the ASEAN Center for Biodiversity leads the implementation of a regional project on peatlands called Enhancing Conservation and Restoration of Wetlands and Peatlands in the ASEAN as effective sinks and reservoir of greenhouse gases, or the ENCOR Wetlands Project, in partnership with Palladium International Limited, with support from the ASEAN UK Green Transition Fund. This two-year project is also in collaboration with the National Research and Innovation, or BRIN, the Global Environment Center, and the World Resources Institute. One of the two pilot sites of the Angkor Wetlands Project is Agusan Marsh Wildlife Sanctuary's Kaimpugan Peatlands, considered as the largest recorded remaining intact peat swamp forest in the Philippines. We believe that strategies and approaches that will be developed from the project will greatly contribute to the local and national efforts in safeguarding our precious peatlands, and at the regional level to contribute to the global biodiversity goals of the Kunming-Montreal Global Biodiversity Framework. More importantly, this initiative will help us work hand in hand with the local communities and the indigenous peoples of our land who are staunch and defenders of nature and enhance their livelihoods with sustainable practices complemented by science-based decisions and actions. As we look forward 2025 and beyond, I encourage everyone, especially our partners from the Philippines, to come together and unite our efforts to ensure that our peatlands thrive, our wetlands healthy, and our biodiversity flourishes. Let us recognize that safeguarding peatlands and wetlands is not only an environmental concern, but a matter of public health and sustainable development towards a future in harmony with nature in the ASEAN region. Maraming salamat po, daghang salamat at maligayang araw ng mga peatlands.
Good morning and warm greetings from Germany to everyone gathered in Bunawan for celebrating World Peatlands Day 2025. My name is Laurencio Constantine and I'm a researcher from the Soil and Site Science group of the Humboldt University in Berlin. And today I will talk about some first results obtained from a soil survey conducted last October in the San Teodoro peatland of the Agusan Marsh, and also talk about some ways peatlands have gotten destroyed around the world and try to show some ways out and some ways forward. Last August, I had the pleasure of getting to know Dr. Grace Nono. We met during an excursion organized by the International Meyer Conservation Group in Germany. I got invited to contribute to soil survey in the Agusan Marsh. So this is how our collaboration began. During my visit to Bunawan last October, a few days of fieldwork were organized. This was done mainly through the efforts of Dr. Grace Nono on behalf of the Tao Foundation for Culture and Arts and Mr. Joel B. Aurelia from the ERDB Forest and Wetland Research, Development and Extension Center. Additionally, we received help from the Protected Area Management Office and Management Board, as well as from the local administration, mainly Senro, Penro, and the local government unit Bunawan and the barangay of San Teodoro. So first of all, I would like to take the opportunity to thank them for making this research work possible and also for their awesome support in the field. This being said, let's start. First, we'll have a look at peat as a soil material and at some general aspects of carbon storage in the Agusan Marsh. The Ramsar Convention defines peat as dead and partially decomposed plant remains that have accumulated in situ under waterlogged conditions. And this is something that you can see quite well in these pictures that actually come from the San Teodoro peatland. On the left, you can see a soil pit, and it's already getting filled in with water, so the site is quite wet. And on the right, you can see a bit of peat, and you can already recognize the plant remains that are partially decomposed within the material. Now let's have a look at how peat accumulates. This example is based on sedge peat. Sedges are a genus of grasses. As you can see, the plants grow, and with every generation, as long as the water level is high enough and the soil is waterlogged, the roots are going to be preserved and not decay because of the lack of oxygen, and the more matter will accumulate inside and above already existing peat layers. So the result you can also see in real life on the right as a fine mesh of rootlets, but based on the vegetation that forms the peat, you can also have an accumulation of mosses, for example, but also of wood in case the community that formed the peat is a forest community. So we saw it is really essential for the soil to be waterlogged so that we can have peat formation. Where does this water come from? For example, in the Agusan Marsh? Well, there are different sources. What is important is that the Agusan Marsh is a floodplain. Therefore, there can be seasonal flooding from the central areas, from the rivers into the floodplain, or there can be precipitations that infiltrate into the soil in the higher areas and flow as groundwater towards the lower elevation. And yeah, let's not forget about the wet tropical climate. The annual precipitations in Bunawan surpass 4,000 millimeters per year. Well, just for reference, in Berlin, we only get about 550 millimeters per year. The source of the water feeding a peatland is important because we can classify peatlands based on this criterion. We have two main categories. On the one hand, we have the minerotrophic peatlands that are fed by groundwater or surface water, basically water that contains dissolved minerals because it has been in contact with bedrock or mineral soil. On the other hand, we have the ombrotrophic peatlands that are fed exclusively by rainwater. This distinction is important also because the peatland chemistry is quite different in these two categories. But not only the chemistry, also when it comes to the terrain, we have differences. Minerotrophic peatlands form in low-lying regions of the terrain. For example, these could be old lake basins that slowly get filled with peat. In the end, the peat is going to accumulate up to the highest groundwater level, and then it's going to stop there. On the other hand, the ombrotrophic peatlands, they can store their own water, and they grow beyond the level of the groundwater and form these dome-shaped structures in the landscape. And indeed, in the Agusan Marsh, we have both ombrotrophic and minerotrophic peatlands. Although in terms of ombrotrophic peatlands, there is only one typical dome-shaped peatland, which is marked in blue on the map. This is the Kaimpugan peat dome, which is also the most extensive peatland mapped to date in the Agusan Marsh. All the other ones are within the floodplain of the Agusan River and its tributaries, so they are mostly minerotrophic. But as I was saying, the precipitations are very high, so the influence of the rain doesn't need to be neglected. But yeah, in terms of classic ombrotrophic peatlands with a dome structure, there is one in Kaimpugan. Not only is the Kaimpugan peat dome the only typical ombrotrophic peatland, but it also seems to be getting most of the attention when it comes to peatlands in the Agusan Marsh. It is really well known for its rare type of vegetation. For example, the pygmy forest in the center of the peat dome. And if you look for international scientific literature on peat soils in the Agusan Marsh, you are going to find articles focusing on Kaimpugan. And among the 3 available articles containing information on the soils of the Kaimpugan peat dome, 2 actually also offer estimates of the carbon stocks, below ground carbon stocks, which are the amount of carbon stored by the soils of a particular site per unit area, for example, per hectare. So there is quite a bit of information available on the soils of the Kaimpugan peat dome, but it is not the only peatland in the Agusan Marsh. So what about all the rest, the mostly minerotrophic peatlands? Is there any information available on these other peatlands that are distributed throughout the Agusan Marsh? Well, there is some information, mostly coming from DENR reports that have been produced over the years. They are based on visual inspection of the site and of the soils. So what has been determined was presence or absence of peat. In the case of the peatlands, obviously a presence of peat, and also the thickness of the peat layer, also information on topography, on the land use. However, there are still some important knowledge gaps. What is still needed is information on the typical botanical peat types, and really importantly, a more exact mapping of the peatland extent. Uh, Something else that still needs to be done are more lab tests for determining soil carbon content in typical soils of these peatlands. And based on this information, it would be possible to eventually produce a reliable calculation of carbon stocks throughout the Agusan Marsh, which would be really useful since the Agusan Marsh and its peatlands are so important for climate protection and for climate protection efforts on a national level. And this is exactly where we are trying to be helpful with our investigations. What we did was to go for a small scale soil survey in only one peatland area, which is San Teodoro peatland, and ask ourselves what kind of soil material we would be able to find, and also see if there might be even more peat outside the confirmed area of the San Teodoro peatland, and also, of course, measure some soil carbon contents uh, in the samples that we collected, and then based on these informations also try first approach to calculating carbon stocks at the investigated sites, only to have a pretty rough idea of how much carbon might be stored in such peatlands that are mostly minerotrophic in the Agusan Marsh. Now comes some information on what we did and also what we've been able to find out until now. So we started by looking at the known extent of the San Teodoro peatland, which goes until around the Bunawan bus terminal to the south, until Poblacion to the north. And what we did were two things. First, we wanted to check whether we can find peat in areas outside the known extent of the peatland. So we chose some promising areas in advance, and then we went to check them out. These areas were mainly located around the bus terminal, also one location close to Poblacion, and a few locations across the Simulao River from Mambalili. And at these locations, we went exploring. We wanted to see whether we find peat. Therefore, we had the spade and the soil auger. The soil auger is this instrument you can see here in the picture. Basically, it contains a chamber that can be pushed into the ground, and after twisting, basically it traps a soil core that can be taken out and looked at. And because this rod is extendable, you can investigate the soil at different depths. So we went looking for uh, potentially new peatland areas. That was one purpose of our investigation, and you can see the points that we checked here in red. These are the so-called exploration points. And additionally, we also focused on this area around the bus terminal and in the southern part of the known peatland boundaries. And we did some more in-depth investigations over there. At the yellow points, the sampling points, we had 5 of those. We also took some soil samples from the extracted cores and submitted them to labs. For once, we had the soil organic carbon checked, and on the other hand, the bulk density of the soil. So we could also officially confirm the presence of peat based on the carbon content, and also try to calculate some rough carbon stocks. Before going on to the results, we'll take a very short detour through the formation of peatlands in floodplains because this is going to be relevant. So if you take a look at river water in the area, for example, at the Simulao River, it is very obvious that water is murky. And it is murky because of a suspended mineral material, which can be clay or silt. And when the river floods this floodplain, then you get clay and silt depositions in the areas adjacent to the river throughout the floodplain. So if we look at this diagram, this schematic representation over here, showing a cross section through a floodplain mire, which is a floodplain peatland, we can see that in phases of flooding, we get these deposits of clay and silt-rich mud, which is a mineral material. And when the water level is basically close to the ground surface, then we get accumulation of peat, so organic material. And this accumulation of organic material and mineral material can alternate so that we get this distinct layering, similar to a cake, let's say. And in other cases, these materials can also be deposited at the same time, so that we get a mix of the two. And this layering is exactly what we found in some of the soils that we investigated in the San Teodoro peatland. Here you have an example on the left where this layering is quite obvious. The dark layers are made of peat. You can tell by the dark color that indicates a high proportion of organic matter. And the lighter it gets, the more mineral it is. So basically, this is a clay or silt-rich mud. And you also get layers that are somewhere in between, where it's not really easy to say whether it's peat or it's not peat, because it contains both organic and mineral material. So yeah, how are we going to decide what is peat and what isn't? Different national and international soil classification systems use different minimum values for soil organic carbon that material has to contain in order to be called peat. We worked with values given by the IPCC guidelines, which are generally between 12 and 18% minimum soil organic carbon, depending on the clay content of the material. And because we expect an intermediate amount of clay, we decided to work with a boundary of 15% soil organic carbon. So everything that has at least 15% soil organic carbon, we would classify as peat. Peat is obviously important to us because it stores so much carbon. But does that mean that any material that is just under that 15% soil organic carbon threshold becomes irrelevant to our study? Well, that is not the case, because even material that is slightly below the minimum soil organic carbon value for peat, for example, let's say 10% instead of 15%, still stores huge amounts of carbon. And nature doesn't really care about our definitions, what we call peat and what we don't. So we also decided to sample all the layers that we found and focus on how much carbon the soil stores overall, not just in the peat layers, but also in the other layers that we could find. Therefore, at our 5 sampling sites, we extracted soil samples from the different layers that we could identify at different depths. In total, we had 36 samples. We put them in bags and sent them to Butuan, to the Department of Agriculture Regional Soil Laboratory, for the determination of soil organic carbon. These are the results of our soil organic carbon analysis. Our samples ranged from 1.29% soil organic carbon on the lowest side to 27.08% soil organic carbon on the highest side. Everything above 15% can be officially called peat. We had 17 such samples with an average soil organic carbon percentage of just above 20%. Then we also had 14 samples that were below the peat threshold, but still with a lot of organic carbon in them, um, between 5 and 15%, so 14 samples. And also 5 samples that had low soil organic carbon contents, below 5%. This is how you can picture these 3 classes of materials. On the left, you have the proper peat, where you can recognize very easily that it is mainly composed of partially decomposed plant materials, but you can really see the tissue, you can see the plant structures in there, and there is barely any mineral material that can be recognized. Actually, what you see are these plant remains. In the middle, we have a mixture. There is still a lot of organic material in form of rootlets of ancient plants that got preserved, but still they are embedded in this matrix of clay mud, this grayish mass. So this is an intermediate form, and on the right you have the clay mud that has very little admixture of organic material. Now, in terms of where we found peat, if we have a look at all of our points, this includes both the sampling points and the exploration points that we only investigated visually. We can see the green dots at the sites where we found at least 10 centimeters of peat within the first 50 centimeters of soil. This is the case both around the Bunawan bus terminal and also close to Mambalili. Both of these areas being at least partially outside the currently confirmed peatland area. So this just shows that more of the landscape than what is currently recognized stores a lot of carbon. Most sites where we found peat, the peat layer was relatively thin of a few decimeters, plus a few extra decimeters of carbon-rich clay and silt mud. But we also had one location in a Falcata plantation northwest of the bus terminal, just inside of the Sancho de Oro peatland area, that contained more than 9 meters of carbon-rich soil, and most of that was actual peat. Um, I say 9 meters and more because we had to stop at 9 meters after our extension rods ran out, so we could not core any further. Probably, yeah, the peat layers would have been even deeper, but we just don't know because we did not have enough extension rods. But in such a deep peatland, the amount of carbon that is stored is just incredible. In order to define the carbon storage at the site, we would need to calculate the carbon stocks. And for the carbon stocks, we don't only need the soil organic carbon, but also to know the bulk density of the investigated layers, which we did measure, but the values are still being evaluated. So we did not integrate everything just yet into carbon stock values for the investigated sites. So we don't have the final numbers just yet, but we can already estimate some probable ranges, and the final value will likely be within that range, and will present some probable ranges for our sites on the next slide. The different points that we investigated will end up with carbon stock values between 100 and 5,000 tons of carbon per hectare for the entire soil depth. The range is so wide because also the soils that we investigated were quite different. Most of them had relatively thin peat layers, and the carbon stocks would be in the range of a few hundred tons of carbon per hectare, whereas this one very, very deep site is going to end up with a value within the thousands of tons of carbon per hectare. As a comparison, we can look up value from literature for the Kaimpugan Dome. There, Fanlia and Lascaux found an average carbon stock of 4,659 tons of carbon per hectare for the entire soil depth. So this is definitely a lot, and if we are going to average our values over the sites, then we will end up with a little bit less. However, we have to look at the extent of the peatlands where these carbon stocks are stored. Again, in light green, we can see the confirmed peatland area. This one over here is Kaimpugan. It is the biggest confirmed individual peatland. However, if we sum up the rest of the peatlands, which are generally minerotrophic floodplain mires, then we can see that area-wise, the other peatlands, the minerotrophic ones, are dominant within the Agusan Marsh as far as the confirmed peatlands are concerned. Further even, our colleagues from the Protected Area Management Office recently analyzed the rest of the territory and identified even more probable peatlands within the Agusan Marsh. These areas are still to be investigated and confirmed as peatlands or not, but if confirmed, they could actually double the extent of peatlands within the Agusan Marsh. And this is actually quite plausible because even our small study showed that there is a lot of peat even outside of the borders of the already confirmed San Teodoro peatland. So this will probably apply for other sites as well. What this means is that there is likely more carbon stored in these minerotrophic floodplain peatlands outside of Kaimpugan peat dome. So this is why it is quite important to also focus some research on them and not just on Kaimpugan, which is already relatively well characterized, and also learn more about carbon storage within the floodplain mires, because as we can see, this whole landscape is really extremely carbon rich and therefore also one of the most important natural allies in climate protection in the Philippines. The Philippines are now slowly catching up to other Southeast Asian countries that have mapped their peatland soils much earlier. Now, in the latest global peatland map from the UNEP, the Agusan Marsh can actually be seen on the map. However, this is not the case for older maps where generally peatlands in the Philippines are just omitted. So this is actually still an ongoing process in the Philippines, and this is why the work that Mr. Aurelia is doing on Mindanao is now really highly relevant, because only by knowing where peatlands are, we can understand their potential for climate change mitigation, and they can also be protected for that purpose. When it comes to the other Southeast Asian countries, well, they have mapped their peatlands earlier. However, in Indonesia and Malaysia, um, a lot of peatlands historically have been heavily affected by human intervention. And in the Agusan Marsh, a lot of this can still be avoided if some lessons from history or from other places in the world can be looked at. And this is exactly what we want to do in the next section of this presentation. So I'd like to briefly show how peatlands have been getting destroyed around the world. First, let's take a look at Germany. In Germany, since the 18th century, there have been large-scale state-financed projects for peatland drainage and the conversion to agricultural land. And this activity has peaked in the 20th century and then also continued on a very high level throughout the 20th century. Removing water through drainage ditches creates the conditions for conventional crops to grow. Nowadays, around 95% of German peatlands have been drained and are used as grassland or pasture or for planting corn or potatoes. And if you look at these areas, you would likely not be able to tell that these used to be wetlands. A very similar process has been happening since the second half of the 20th century in the tropics as well. It's just different crops that have been established after drainage projects, for example, rice or oil palm very common throughout Southeast Asia, or in South America, for example, also potatoes. Another important driver of peatland destruction has been urbanization and the expanding infrastructure. A lot of peatland area has been drained and excavated for different projects for housing or for building roads, airports, and so on. And this is a trend that is most notable in developing countries with a growing population. Peat extraction must also be mentioned. Historically, peat has been cut and dried in order for it to be burned for heating. And nowadays, peat is being extracted mainly for a different reason. Peat gets milled and prepared as a raw material for gardening substrates, but it has to be said that not any kind of peat works for this purpose. It has to be sphagnum moss peat from ombrotrophic peatlands. What all these pressures have in common is that they are centered around peatland drainage. And what drainage does is that it makes oxygen accessible to microorganisms in the drained peat layer, and they transform through aerobic oxidation the organic matter to carbon dioxide and nitrous oxide, which are greenhouse gases. And deeper drainage leads to even stronger releases of these greenhouse gases because air enters a higher proportion of the soil, and this is also helped by cracks that form in the peat after drainage. This is how almost 2,000 megatons of CO2 equivalents are released globally every year. And this makes up around 4% of global anthropogenic greenhouse gas emissions. We can see the leading country when it comes to greenhouse gas emissions from peatland is Indonesia. Russia is the second. We can see Malaysia is also top 5, and Germany, even though it's a relatively small country and doesn't have such a large peatland area, it still makes the top 10, and emissions from drained peatlands make up for more than 7% of total anthropogenic greenhouse gas emissions in Germany. Drainage comes with an additional risk factor. The dry drained peat layer can catch on fire very easily, and existing cracks make this effect even worse because the fire can burn underground. It can do that for weeks and is very, very hard to extinguish. Just an example, these are some spectacular surface cracks that I found last October on a drained peatland site in San Teodoro. And of course, peat fires are a well-known problem in Southeast Asia, mainly Indonesia, but also the rest of the world, with devastating effects such as massive releases of CO2, with air pollution, with increased risk of soil erosion, with habitat loss, and also the loss of cultural value. It is also important to note that after drainage, the drained peat settles under its own weight. It also shrinks because water is leaving the pores, and then the loss of organic matter through peat oxidation, they all lead to a loss of volume of the soil. This is why we have subsidence. Yeah, subsidence is the total loss of elevation caused by these three processes. And the subsidence can amount to a loss of several meters of elevation after a few decades of drainage. Now let's look at an example of subsidence from drained peatland in Indonesia. This particular site was drained in 1979. Next to the upper yellow band on the metal rod, you can see where the land surface would have been in 1979. This photo was taken in 2007, and have a look where the land surface is at that point. So in just 28 years, this site has lost 2 meters and 30 centimeters of elevation. Subsidence of this magnitude is really problematic in low-lying areas that are close to the sea or to rivers. They are much more easily floodable. They are at risk of saltwater intrusion, also of coastal erosion. And just have a look at this picture taken in northern Germany along the Trene River that has flowed over the dikes and has flooded all the adjacent areas that were affected by subsidence. Because subsidence is often uneven and also shrinking and swelling takes place in peat, very often infrastructure projects built on peat soils fail, like this road in Sarawak shown on the slide. But whoever has experience driving on the roads of Agusan del Sur will probably find this image quite familiar. And I suspect there are good reasons if we think back at the materials that we found on our soil survey, which means peat and also clay-rich muds, both very prone to shrinking and swelling. So really materials that are very hard to build upon any kind of structure. By the way, failing infrastructure on peat soils is not something that only happens in Southeast Asia. This is a picture from Germany, where a highway was built over a peatland, and then in 2017 it collapsed like this, very, very spectacularly. So yes, it is very hard to build lasting, secure infrastructure on peat soils. So it always the question has to be asked whether it is really worth it. Also, just draining the peatland and converting it to agricultural land doesn't necessarily mean that the crops are going to do well. Depending on the site, peat can prove to be ill-suited for conventional crops because moisture conditions could prove to be unfavorable because of subsidence, because of potentially a lack of nutrients, also because of the low bearing capacity of the soil that could make management with heavy machinery impossible. So uh, just transforming the peatlands into conventional agricultural fields doesn't necessarily mean they're going to be profitable. And some examples we could also see on our field trips last October in the Agusan Marsh. For example, there is quite a lot of abandoned rice paddy. I've been told it's because of failing crops. Also, on the site where we had this 9-meter deep peat soil, the falcata trees were underdeveloped for their age. So peat is tricky. It doesn't necessarily make a good agricultural land even when drained. So again, in order to extract the best value from a peatland and also not damage it unnecessarily, it is best to understand how peatland work, um, what value they hold, and also what potentials they hold for more sustainable use. This being said, I will move very quickly through the last few slides of the presentation on ways forward. Wet natural peatlands are really the best at providing important services like climate regulation, like water flow regulation, habitat for valuable species, for example, including medicinal plants. And once they are affected, it is very, very hard, nearly impossible for them to regain their functionality the way they had it in their pristine state. Therefore, the rule number one is to really conserve wherever possible, wherever there are peatlands that are still pristine, it is really worth conserving them in this state. But of course, livelihoods also have to be secured. So for the future, in comes the idea of paludiculture. Well, paludiculture is a paradigm shift from adapting site conditions to the requirements of conventional agriculture to adapting cultivation to permanent wet conditions. Therefore, cultivating plants that thrive under wet conditions already. And this would result in significantly lower environmental impacts. Crops can be used for, well, anything, for food, medicine, as raw materials, fodder, or even fuel. And this is a good option, for example, for lands that have already been drained. Transforming them to paludiculture would definitely be a significant improvement. Among the most common paludiculture trees in Southeast Asia would be the rubber tree or also the sago palm. There are also other options, and I am not going to go too much into detail because Dr. Hestiles Taritata is going to offer much more information on paludiculture this afternoon. An additional potential economic benefit that goes hand in hand with peatland conservation and paludiculture would be ecotourism. Unique local landscapes, local knowledge and traditions, as well as new ideas of using the landscape in a sustainable way. These are all interesting topics that could be explored by visitors. Building non-invasive boardwalks or traditional houses could help visitors learn more about the local landscape and culture, and also, of course, benefit the local economy. There is some experience with that in Indonesia already, so I guess there can be inspiration that can be taken from there in terms of ideas and marketing and so on. The Agusan Marsh is so rich with beauty and with traditional knowledge. These are things that for sure create a sense of belonging and of identity. And this is something that should definitely be kept along the way to a prosperous future. And finally, a brief summary of the take-home messages. So we found peat outside previously confirmed peatland boundaries. We also saw that minerotrophic floodplain mires in the Agusan Marsh store a great amount of carbon, and a publication is in preparation on that topic. But also further large-scale, more systematic studies are needed in order to identify peatland boundaries and estimate carbon stocks reliably. Then we saw that around the world, drainage-based activities have impacted the climate regulation function of peatlands. So a shift towards managing peatlands in a wet state is necessary. There are some promising options for that, including paludiculture, and very importantly, peatlands need protection. This is how we avoid costs of climate change, flooding, peat fires, and also safeguard livelihoods, landscape, and cultural heritage. This is all for my part. Thank you so much for listening. Salamat kaayo. And I wish you all a really, really lovely World Peatlands Day. Hello again. This is Laurencio Constantine, all the way from Germany. I hope everyone had a great lunch and also very interesting, exciting field demonstration with Mr. Joel Aurelia. Now we are back, and I would like to say a few words about peatlands in Germany. So I will start by saying that if you were to ask an older German person about what they associate with peatland, they would say something like, "Oh, these are these spooky, barren places uh, where there are stories of small lights appearing from place to place, leading travelers astray, and they would never be seen again." So it would have been this dangerous but also magical place. It's something um, more like you can see on the left side of the screen. Well, in the meantime, Germany has drained almost all of these places. Mostly during the 20th century, there have been really massive drainage campaigns and reclamation campaigns for transforming peatlands into agricultural land. This happened to about 95% of the original peatland area. It did have pragmatic reasons. There was a lot of fodder production for cows, so it was used for milk production. But with time, we became aware of the climate crisis and also realized that drained peatlands are huge emitters of greenhouse gases. If you were to take the sectors agriculture and land use, uh, the greenhouse gas emissions from drained peatlands would make up 40% of these sectors. So this is huge. Um, Therefore, there is a need to turn this trend around and keep the peatlands wetter, diminish the greenhouse gas emissions, and also restore at least some of them to uh, um, a state that is closer to their natural state. And something like this has been happening lately. Here we can see another example of heavily used peatland, not for agriculture, but for peat extraction. But lately, these places in Germany have turned from this to this because Germany is phasing out peat extraction, and the remaining peat extraction companies, they are supposed to restore the peatland and help the original vegetation grow back after they are done with peat extraction. This is not great since the peat has been extracted, but this just shows the trend that now in society we value the natural state of the peatlands more. And a lot of these areas that used to be used for peat extraction or also old agricultural lands with peat soil have been acquired by um, local communities or by nature conservation foundations, and they implement rewetting measures and also educational measures for visitors, for raising awareness and building knowledge on the importance of peatlands. For example, this is one of my favorite ones from the peatland called Allenmoor in northern Germany, which also used to be part of a peat extraction site. Now they have constructed this causeway for people to be able to explore the still natural areas and also the restored areas, and even the little train that was used back in the day for carrying the peat out is now used for small tours for sightseeing in the peatland. So these are quite fun activities that also bring tourism to the area. There are also workshops for interested citizens, also for children. They can learn about native vegetation. They can run barefoot through the mud. There is a lot of emphasizing the beauty and fun of these natural and restored peatlands, and of course the importance of peatlands for our climate. So nowadays, if you ask a young person what they associate with a peatland, the most common answer is going to be, "Oh, aren't those those places that store a lot of carbon and are important for the climate?" So really, this uh, awareness raising campaign has really worked quite well in Germany, at least for on this side. Germany is quite okay. People have also started to use less products that come from peatlands that are drained, or they use less peat for gardening. So people are more and more aware about um, conserving the peatlands in their natural state. Even though there is a need for a really large-scale rewetting, there Germany hasn't been that efficient yet. Things are moving quite slowly, but at least when it comes to education and raising awareness, a lot of good things have been done. And yes, why not? This can be also done in the Philippines, and I hope this will happen because the landscape is really amazing in the Agusan Marsh. Here, you can see us on one of our exploration days. It's Dr. Grace Nono and Joel Aurelia and myself and the rest of our field team. Here we are on a natural site that was really interesting. Imagine where we stand, there is around half a meter of peat, of intertwined, half decomposed plant material, and underneath it's water. It's basically like a water mattress on top of a lake. So when we were walking, the whole ground was shaking like this. It is something very interesting, and unless you've experienced this, you might not know that such places exist. And once people get to know and experience the beauty of these places, they will for sure also be motivated to protect them. And even though there is a trend to develop, and of course it is important for livelihoods to be secure, it is also important to preserve the local characteristic and the beauty of this place. So this being said, I wish you all the best. Thank you for having me here, and have a great Peatlands Day. Bye bye.
Dear ladies and gentlemen, dear peatland lovers, I wish all of you a very happy World Peatlands Day today, as we are all celebrating peatlands worldwide and at our home places together. My name is Jan Peters. I'm the Managing Director of the Michael Succo Foundation, which is one of the partners in the Greifswald-Meyer Center. I'm situated here in Greifswald, northeastern Germany, very close to the Baltic Sea, and we are not only caring and studying and restoring and conserving peatlands, but we are also surrounded by peatlands around us here. So I'm quite often sitting in peatlands, I'm appreciating them, I love to study them, and I love to have different perspectives on them. So I was very glad to host Grace Nono last year at her Climate Action Fellowship in Greifswald and explore some of the peatlands around us. Peatlands are real superheroes. They store huge amounts of carbon. They store twice as much carbon as all forest biomass in the world, although they are only covering 3% of the land surface. They are acting like sponges. They keep the water in them and store it for drought situations, for example, to release it then to the surrounding landscape. But they are also purifying water to provide good and high quality fresh water for drinking, but also agriculture and other usages. And they host a wide variety of unique biodiversity, plant and animal species, which are specifically adapted to peatlands, as they are very extreme ecosystems, very wet, quite often very acid, quite often with a lot of with very few nutrients. So all these species which live in peatlands are very well adapted and can only live there and nowhere else. So they are, in many countries, they are very much under danger and endangered. Worldwide, we still have around 90%, a little bit less, of the peatlands in a relatively good state, almost intact. But we have also 10%, a little bit more than 10% worldwide, which are degraded. And the strange fact is that these almost only 10% of the degraded peatlands release 4 to 5% of all anthropogenic greenhouse gases. So if we imagine that the rate of degradation, mostly by drainage for agriculture, for forestry, but also for extraction of peat, is continuing at an alarming speed as today, we would lose more of it, and the anthropogenic share of greenhouse gases would even rise. On the other hand, we have countries like, unfortunately, Germany, where I live and come from, where we are like champions in destroying peatlands by drainage. In Germany, not only a little more than 10%, but 95 and more percent of the peatlands are drained. That started already in Middle Ages, so hundreds of years ago, but the main peatlands had been converted by drainage into agricultural lands, some also to peat mining, extraction for energy purposes in the last 100 years. And this causes enormous harm to the nature, but also to the society, to us people. The greenhouse gases from peatlands in Germany make up 7.5% of all anthropogenic greenhouse gases in Germany. This is the same amount as all steel production is contributing to the greenhouse gas emissions in Germany. So quite a high share. And we also have the problem that we have subsidence. So the peat is decomposed, the CO2 goes up into the air, but this also means that we are losing land. And as many peatlands in Germany and also in other countries are close to the coast, and on the other hand, we have rising sea levels, we have enormous problems in future, but already now with the risk of flooding of these lands and saltwater intrusion to these lands, but also to the infrastructures, to the sanitation and the road system, for example, which is very costly and creates a lot of dangers in the future. And also we see that in Germany, as in many other European countries, the species, the peatland species, which are on the red list, are the highest. So really peatland species and biodiversity is under threat in Germany. That's why we really have to restore peatlands. Conservation alone is not enough because there's almost nothing left. So we have to restore. And the good thing is that we have legislation in place now. We have from the European Union level, we have the nature restoration law, which gives percentages of land which needs to be restored till 2030, 2040, 2050. So also mid and longer term goals. And we have in Germany a national peatland strategy, which is should contribute till 2030 to reduce emissions by 5 million tons CO2 equivalent emission per year, which is only 10% of the total emissions which we have at the moment, but at least it would be a start. And it's also made up by a consultative and participatory approach with stakeholders, with the administrative structures and so on and so forth. And the new government here in Germany, which came into power few weeks ago, they also confirmed that they want to follow that strategy. On the other hand, we also have an action program for nature-based solutions, which gives or should give funding for restoring peatlands in a better way. But this is quite slow, and we see that public funding alone, although it's needed, cannot solve the issue. We also need private stakeholders to restore and re-wet their land, so to raise water levels again. And this, for that, you need to have incentives because you cannot force them to do it. And these are mostly landowners and farmers owning and managing agricultural lands. So we urgently also need new ways of utilizing these peatlands. That is then a form of wet peatland agriculture, what we call paludiculture, where you can use the biomass which grows on these wet peatlands. They are quite often very productive lands, and use it for packaging material, for construction material to insulate or build your houses, but also for substrates, for example, in horticulture, and so on and so forth. So there are plenty of ways to use these materials in a bioeconomy. So we need a lot of exchange. We need a lot of new methods, innovative thinking, and to solve that issue, because it's more than clear that the business as usual, as we are dealing with peatlands at the moment here in Germany, is not sustainable at all. And if we look at the global pictures, we see that we have a really high responsibility to do something to restore our lands here and also take the burden of doing so. But on the other hand, we can definitely also benefit from it to create new ways to harvest biomass, for example. So that's what we want to do. That's what we should do here in Germany. And on the other hand, it's also very crucial for us to say that drainage and degradation of peatlands in other parts of the world is not the way. You should not follow the very bad example from Germany in this, actually. But you should, if you still have, and I know that, for example, in the Philippines, there are still a lot of intact and functioning peatlands. You should keep them. You should conserve them. You should value them. You should enjoy them. You should also create new approaches to it, and you should see what you have, do some inventory, some mapping, so that you have like a better overview, but then also try to find ways how to involve stakeholders, all kinds of people, so that you can really that you can really keep them for future generations, and also to keep our climate and our unique biodiversity and our water cycle safe for the future. That's what we work together for. That's what we cooperate for today on World Peatlands Day. I would love to be there with you, but I'm celebrating the World Peatlands Days and all the peatlands globally, and here at our home in Greifswald. And I wish you a very nice day, a very nice event, and hope to see you very soon. Thank you.
Hello everyone. On this occasion, I would like to acknowledge the organizing committee whom invited me as a speaker on this event. Let me introduce myself. I'm Hesti Lestari Tata, a researcher of the Research Center for Ecology and Ethnobiology, the National Research and Innovation Agency, or known as BRIN. I would like to share my knowledge and experience about paludiculture practices in Indonesia towards sustainable peatland utilization. Here are some figures of natural peat swamp forest ecosystem. On your left is a Begantung Lake Central Kalimantan in Kalimantan Island, while on the right is a Zamrud National Park in Riau, Sumatra Island. Peat swamp forest ecosystem is a habitat of flagship species such as orangutan and various plant species which provide many benefits for human beings. Peatlands are spread all over the world, from the tropic to the temperate and boreal biomes. In Asian continent, Indonesia has the second largest peatland area, totaling of 13.43 million hectares according to Anda et al. 2020. Among the Asian countries, Indonesia has the largest peatland area. Tropical peatland occurs within 11 Asian countries, including the Philippines. Peat formation has been classified based on water resources, which falls into topogenous and ombrogenous peatland. Tropical peatland in Indonesia are mostly categorized as ombrogenous peatland, as Osaki hypothesized that peat formation is found in this figure. There are three stages of peat formation. The land is positioned between two rivers and they are deposited by organic matters. Due to anaerobic condition, the organic material decomposes very slowly and it forms peatland. Here is the profile morphology of the peat soil and performance of peat decomposition. According to soil definition, peat is categorized as histosol type, which contain at least 12 to 18% organic carbon and whose thickness is at least 40 cm. Well, according to the regulation in Indonesia, the thickness of peat is at least 50 cm. Despite of various benefits, many peatlands in Indonesia have been degraded owing to mismanagement and over-exploitation. The forest vegetation have been cut, the peatland were digged, and canals were established to drain the peatland. This figure shows canal networks in the ex-Megarise project in central Kalimantan. The extensive canal network drained peat water, and peat dome and peatland became dry and susceptible to fire. Peatland degradation also resulted floodings, as reported in the news, and also predicted hydrological modeling, as reported by Sumarga et al. And also Lupasco et al. Drainage causes other damages. The economic cost of fire 2015 to Indonesia was estimated 16 billion US. Other damages such as peat subsidence and greenhouse gas emission. The haze of fire produces particulate matters which cause pulmonary disease and threaten human health. Can we restore the degraded peatland? As a wetland ecosystem, peatland must be wet, so then conserve the remaining pristine peat swamp forest, and we must apply strategies on peatland management and peatland restoration. Some strategies of peatland restoration consist of rewetting, revegetation, revitalization of communities, fire prevention and control, policy support, and law enforcement. FAO has proposed decision support for management of peatland soil and organic soil. In the left side can be applied in the wet organic soil or undrained peatland, while in the right side is for drained peatland. When rewetting is not possible, then fire control must be applied. Culture can be applied in the wet and rewetted peatland. The concept of culture is to conserve soil and protect climate through minimizing CO2 emission and control CO4 emission. How it can be applied? By water management, controlling groundwater level. According to Indonesia regulation, groundwater level in the cultivation zone of peatland hydrological unit is maintained no lower than 40 cm. There are several benefits of culture, namely prevent fire, reduce emission, reduce subsidence, improve local livelihood, and conserve species. However, there are several challenges of promoting culture. Not only few species provide marketable good, less marketable good, long value chains, need economic instrument support system, and social inclusion. Here is some example of marketable goods, mostly food, like honey, stingless bee, fish, pineapple, coffee, and others. And here is example of less market goods such as gum, purun, latex, opdera, and resin. It also has a long supply value chains from farmer, middleman, processing, collecting, manufacturing, wholesale, and to retailing to consuming. It is the example of value chain of sagu in Kapuas, Central Kalimantan. Culture needs economic instrument support system such as positive incentive, negative incentive, extension, and technology development. R&D program, infrastructure, and equipment support are included here. Social inclusion and community engagement in peatland restoration accelerate the success of restoration. The restoration must provide benefit for the communities. Some opportunities of culture development is not only provide economic benefit but also increasing awareness, regulation support, finance support, collaboration among quadruple helix, and it aligns with global agreements such as SDG, Paris Agreement, forest and landscape restoration, and others. Culture is a climate-smart peatland management and the potential for synergies between food security and climate change objective in Indonesia, as reported by Lupasco in 2023. Here is some study case of establishment culture plot in Sumatra and Kalimantan. The first is culture technology to restore degraded tropical peatland in Central Kalimantan. We planted four native peatland species and plant Malaleka Cajeput as intercropping. The second is peat forest rehabilitation in the forest with specific purpose of Kepau Jaya in Riau. We planted two species, Soria balangiran and Coffea liberica, interplanted in the existing oil palm. The third is rehabilitation of peat forest reserve of Bram Itam and Londrang in Jambi province. We planted 11 different species in two different sites. And domestication of Euterpe oleracea to provide food from peatland. It was on an early experiment of Euterpe domestication. This plant is flooding tolerant and has various benefits, so promising for food security and provide nutrition. As a conclusion, polyculture is a promising option for reducing GHG emission of green agricultural peatland, and polyculture has lower direct GHG emission than agricultural use, and the polyculture product as green and low emission product needs support from government and private sector for market development. Thank you for your kind attention. Here is my email for further information. Thank you. Bye.
Mapianaan daw.
Gawas nga oras kada ka-MN.
I'm Willie Jones B. Saliling
I am Yvonne V. Saliling of the University of Southern Mindanao.
The University of Southern Mindanao is a state university.
Located in the municipality of Cabacan, province of Cotabato.
My specialization is in hydrometeorology, where I studied the interaction between meteorology and hydrology. In terms of the study of the Liguasan Mars, I'm very much interested in the way the Mars behave as a sponge for floods and how can we mitigate disasters caused by floods. But then the concept of Mars protection, the concept of biodiculture, and the concept of peatlands restoration come into fore. We have our visit to Bunawan last year with the invitation of Dr. Grace Nono. And from there, we have been able to look into a wider picture on the marsh protection, particularly in Liguasan Marsh. Several challenges have been faced by the Liguasan Marsh nowadays. One of them is the declining water quality caused by rapid agricultural expansion and urbanization. Our biologist here in the university has pointed towards this dilemma because of the rapid urbanization and the expansion of banana plantations and some oil palm plantations. But nevertheless, it points out towards action that the researchers will have to do to aid our decision makers towards science-based policy making.
Another challenge is on the unawareness or lack of awareness of the people on the significance of the Mars, because it has something to do or it has implication on how to protect the Mars and how to preserve the flora and fauna found within it or nearby the Mars. Further, on the management, because of its transboundary nature, wherein the Mars traverse in the different provinces of Soxargen and Barm.
It is for this reason that we have proposed an extension project titled Innovation Laboratory for Sustainability and Resilience in Local Governance, or
SureGov.
In SureGov, we'll try to put together science and policy, hydrology, biodiversity, social studies, disaster risk management into one fold in order for us to effectively collaborate with the local government units. After collaboration, we are going to look into different approaches, different solutions. We co-create solutions in a way capacitating the community.
In SureGov, we
Collaborate,
co-create and capacitate. We are looking forward for a stronger partnership with you in Peatland's restoration.
Bring the waters home. Bring the waters home. Bring the waters home. Bring the waters home. From vapor to liquid to ice. Shapeshifter, mother of Where's the water's home? Where's the water's home? Where's the water's home? Where's the water's home? Though home's everywhere, she does stay. Long in Peatlands where she feels safe. Red water, groundwater is buffered and filtered and stored. Keep the waters home. Keep the waters home. Keep the waters home. Keep the waters home. When water is home with peatlands, many are blessed by their dance. The birds and the fishes, the humans and trees, beings all bring the waters home. Bring the waters home. Bring the waters home. Bring the waters home. Where's the water gone? Where's the water gone? Where's the water gone? Where's the water gone? But how broken land has become, dry as a bone in the sun. Sucked of its lifeblood and kindling, but one never burns. Bring the waters home. Bring the waters home. Bring the waters home. Bring the waters home. The water they say is never lost. Salt water can't quench thirst and drought. The world needs fresh water, sustain a mother root. Bring the waters home. Bring the waters home. Bring the waters home. Bring the waters home.